Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph y equals negative secant of pi over 2 times x plus 2. And I believe that was it, right? Yeah, okay. So when graphing secant, we want to obviously go ahead and graph the reciprocal function, which is going to be cosine. So I'm just going to write that in there, y equals negative cosine of pi over 2x plus 2. Because the graphs as well as the function are very much related to each other. So what I'm going to do is graph cosine first with these transformations, and then go ahead and draw the secant graph from that graph. So to first do this, I need to be able to determine what are all the important parts of this cosine graph. So I'm going to want to start by finding the amplitude, the period, the x scale, the phase shift, and the vertical transformation. Now, the next thing that's also important is understanding, how we're going to find all this information. Well, to go ahead and do that, we need to kind of have a transformation equation for this, which is y equals a times cosine of bx minus c plus d, where a, b, c, and d are going to be all the different transformations that are going to affect our graph. All right, so the period is going to be the absolute value of our a. Well, in this case, the absolute value of a is -1. So absolute value of -1, is just 1. Period is going to be 2 pi divided by b, which in this case, b, you can see what is the number that is being multiplied, that is in front of the x, or is multiplied by your x. Right there, you can see is pi halves. So I have 2 pi over pi halves. So to simplify that, I'll just multiply by the reciprocal. That multiplies the 1. Here, the pi's will divide out, and I'll have 2 times 2, which equals 4. To determine the x scale, all I'm simply going to do is take my period and divide it by 4. So in this case, I have 4 divided by 4, which equals 1. Phase shift is going to be how the graph is going to be moving left or right from the initial period. And the way that I like to think about phase shift is if you look at the initial period, we can say that the cosine graph or the sine graph, start at 0. But really, they're harmonic. They can continue on forever and ever. But the initial period, you can say they start at 0. So if there is a phase shift, then I prefer to start at wherever the phase shift is at. So let's go and see to determine the phase shift, all we simply do is take whatever's inside of our parenthesis and set it equal to 0. So in this case, we have pi halves x plus 2 equals 0. So I subtract 2, pi halves x equals -2, and then just simply multiply by the reciprocal, which would be 2 over pi, 2 over pi. Oh, I did have that. That was pi halves. My bad. Okay, so I subtract pi halves. I knew I made that mistake. Okay, so then we multiply by 2 over pi, 2 over pi. Sorry, I had the problem wrong. Nothing else has changed, but this was plus pi over 2, not plus 2. And I couldn't remember if I wrote it wrong on my piece of paper, and I just figured it'd be that way. But this makes sense. So nothing else that I've done so far has changed. The only thing it affects is now it's phase shift. Because now, to get the phase shift, I have to subtract pi over 2 on both sides. So now I have negative pi over 2. I multiply by the reciprocal. And here, you can see that now this multiplies into -1. So therefore, my phase shift now has my graph starting at -1 rather than at 0. And the vertical translation is equal to d, which is going to be, does the graph shift up or down at all? And since there is no d, we have none. OK, so now let's go ahead and graph the cosine graph. And once we graph the cosine graph, once we have the cosine graph, then we can go ahead and get into secant graph. Now, let's pretend here is 0. Now, I said I wanted to start at -1, right? So let's go a little bit farther out and say, all right, there's -1. That's 0. That'd be 1, 2, 3. Now, the reason why I'm going by a scale of 1 is because that's my x scale, right? I said go by x scale, so I'm going to go through my x scale. Remember, there's 4 x scales that we're dealing with. So 1, 2, 3, 4. That is going to complete 1 period, right? A period is a distance of 4 x scales. So 1, 2, 3, 4. So that's 1 period. And let's do it again. 4, 5, 6, 7. Okay? So now, to graph this, we just need to understand what the parent graph looks like. Remember, cotangent, if the initial period, let's say, oh, and the amplitude is 1 and -1. Now, there's the other thing also we got to see is, remember, this a is negative, right? So that means I have a reflection over the x-axis. Whenever your a is less than 1, you're going to be reflecting over the x-axis. So in the parent graph, we typically started at 0 and we started up at 1, right? Well, since we're reflecting over the x-axis, we're going to now start at -1. And then, since we have a phase shift, we're going to start at -1 on the x-axis. So then the next point would be at 0. Next point would be up the maximum, minimum. And let's just go ahead and graph this in and see if this makes sense for initial period. Does that look like the graph is ready to repeat itself, exactly consisting of 1 period? Yes, it does. So then I'll just continue this pattern. OK, perfect. So you can see that now I have graphed 2 periods of the cosine graph. Now what we actually need to do, though, is graph secant. Now, again, notice that I did a phase shift. I shifted the graph over -1. I reflected it over the x-axis. And those are my two transformations. And the period is 4, I guess you could say. But that's not really a transformation. But it's been, well, I guess, yeah, it's been compressed over or expanded. Compressed over to 4, a little bit smaller. So now, what we need to do is graph the secant. So secant is, remember, wherever there's an intercept on the secant, or on the cosine graph, that is going to produce a value that is an asymptote for the secant graph, right? Because remember, these are reciprocal functions. So if you're going to create a table of values, if x represents the point on the circle for cosine, then it's 1 over x for secant. So at each of these zeros, since these are all zeros, if you put 1 over 0, then they're going to be undefined for secant. Then I just go to each maximum and minimum, and I create nice little parabolas, and that's the shape of them, that are going to be approaching your asymptotes, right? Because remember, when we have asymptotes, they are approaching in an asymptote. So there you go, ladies and gentlemen. That is how you write y equals, or graph y equals negative secant of pi over 2x plus pi halves. Thanks.